Hi, welcome to our next lesson dealing with dividing monomials. The objective is how do we simplify expressions involving the quotient of monomials and negative exponents. So, quotient of monomials. We have an example where it's 4 to the 5th power divided by 4 to the 3rd power. If you remember from multiplying monomials, when you have the same base, you add the exponents. But when it comes to dividing powers with the same base, you will subtract. Oops, before I do that, it says the rule to divide powers with same base, subtract the exponents. And then here we have the rule where a to the x divided by a to the y, a is the same base, so you're going to subtract whatever value for x and y from it. All right, so we're going to use this example, 4 to the 5th over 4 to the 3rd. Basically, you can rewrite it as 4 to the 5 minus 3 power. So it's because the same base, you can subtract, and it gives you 4 to the 2nd power, and that's your answer. Or, imagine you having 5 4s on the top in the numerator, and then 3 4s at the bottom. So if you were to cancel out how many you have at the top and the bottom that are the same, this is what you would be left with. So I'm going to use wrong color. I use blue instead. Alright, so cancel this one, you can cancel that one. There's one here, you can cancel another one down here. Another one on top, cancel down here. What are you left with? There are 4 2's that you're left with, so then that means it will be 4 to the 2nd power. Same thing that we had when we did it the other way, where we subtracted the exponents because they have the same base. So that's what the rule is about when you're dealing with quotient of monomials. Same base, they're being multiplied, they're being divided, subtract the exponents. Alright, so we're going to look at 2 examples where we need to simplify the polynomial, the dividing monomials. So the first thing, we got a to the 5th, b to the 8th, over a to the, it's the first power, that's that invisible 1, times b to the 3rd power. Right, so you can rewrite it this way. You have the same base for a, so you can subtract the exponents, 5 minus 1, and b, same base, subtract the exponent, 8 minus 3, simplify, and you have your answer a to the 4th times b to the 5th. Okay, let's look at the next one. We have this dividing monomial to the raised to the 4th power. So remember what we mentioned about when there's a power outside, you treat it as if though you're doing the distributive property, but you're dealing with exponents. So in this example, took the 4, multiplied it to p to the 2nd power, and then also to the 2, and I also did that for the 3, raised it to the 4th power. So you do whatever you do on the top, you're going to do the same thing in the bottom, because that 4th power is for both denominator and numerator. So once you do that distributive property, basically you're raising the each term to the 4th power, so 2 to the 4th, p to the 2nd to the 4th. Remember when you have power raised to a power, you multiply, and then 3 to the 4th. Then you simplify your numbers. So 2 to the 4th gives you 16, 3 to the 4th gives you 81, and then you have the p to the 8th in the numerator, and that's your final answer. This can't be reduced because 81, 16 and 81, that's already reduced, so you leave it as is. But anytime you have a fraction that you can reduce it, so you are simply simplified, if that makes sense. Alright, next thing, power of 0. So we have a chart, we have a power, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0 power. So let's see what the value is. Basically, you would plug it into your calculator. You would do 2 to the 4th. If you're not sure how to do that, you put 2 and that little hat that you see, it looks like a little mountain shape, a tiny shape that's like a hat. You click on that and then you press 4. You should get 16 when you press enter. Same thing for 2 to the 3rd, 8, 2 to the 2nd, 4, 2 to the 1st is 1. And what do you think what happens when you get 2 to the 0 power? Some of you might say 0, but if you put in the calculator, it will give you 1. So the rule is any base raised to the power of 0 will always equal 1. So if you had a to the 0 power, it will be 1. If you had, let's say in parentheses, the word base to the 0 power, that will equal 1. So again, any base raised to the power of 0 will always, and I'm going to underline the word always, equal 1. So let's look at this example. We have 2 to the 4th over 2 to the 4th. If you say that it's equal to 1, then I will say that you are right, because any number divided to itself will give you 1. But let's break it down. So we got the same base. You subtract the exponents. It'll be 2 to the 0 power equal 1. Or if you were to simplify this one, 2 to the 4th gives you 16, and 2 to the 4th, 16 equals 1. So again, we've proved that even though you simplified it, the same base, same power, but again, the result would be 0 as your power. Whatever that base is to the 0 power will give you 1. And this just backs up your proof. Okay, next one. So we're going to do example dealing with raising whatever base to the 0 power. So here we have dividing monomial. Again, break it down. So I broke it down where I'm raising 0, raising the monomial, the numerator to the 0 power and the denominator to the 0 power. Again, you're treating it as if you're doing the distributive property. So you're raising 0 each term to the 0 power, as you see here. And then notice that everything is raised to the 0 power. So what is it going to all equal? The first one is going to be 1. X to the 5th to the 0 power is 1. Y to the 0 power is 1. All of them 1, 1, 1, 1, 1. You simplify 1 divided by 1 gives you 1. So instead of doing all of this work, anytime you have any base or anything that's in a parentheses raised to the 0 power, your answer is 1. So you wouldn't have to do all of that work. This would be the only thing you need to put, 1, because you're raising it to the 0 power. Let's look at the other one. Okay, we have same base, t and t. That's that invisible 1 power of 1. And then we have s to the 0 power. So again, if you were to break it down, you got same base, t to the 3 minus 1 power, s to the 0 power. So then you got t to the 2nd times 1. And anything times 1 is going to be itself as a result. And you got t to the 2nd power. Right. Negative exponents. All right, we have another chart again. We have all of them raised to the powers, and we notice that the 2 is raised to the negative powers. So let's see what the value is. Again, you can do this on your calculator. You already know with 2 to the 4th is 16, 3rd, 8, 2 to the 2nd, 4th, 2 to the 1st is 2, 2 to the 0 power is 1. Now when it comes to negative exponents, if you were to plug that into your calculator, you would put 2, then that little hat that tells you you're raising the power, and then you put it in parentheses and type in -1. But if you have a graphing calculator, it will have that little box that shows up when you're raising it to the power. You just put -1, -2, -3, and so forth, press enter, and then you'll get your number. But for this one, if you have your value for that one, it would be 0.5. 0.5 is the same as a half. And then this one would be 0.25, which is a quarter. And then you have 1/8. And then this would be 1/16. Now, when it comes to negative exponents, why did we get this instead of getting 2? Or 4 and this instead of getting 4? But notice the pattern. Notice that whatever you had, for example, like 2 to the second power, it was 4. But when you did 2 to the negative power, negative 2 power, you have 1/4. So it looks like any value you had when you raise it to a positive power, when you do it with a negative power, it's 1 over itself, the number. So it's the reciprocal. So with that rule, it says negative exponents must be made positive by taking the reciprocal of the entire exponent expression. So basically, if you had a, anything that would be a value of a to the negative x, will equal 1 over a to the x power, positive x power. Or if you had 1 to the negative 1 over a to the negative x power, it will equal a to the positive x power. So again, if you see a negative exponent, do it as if it was positive, raise it to that positive power, and then do the reciprocal of that number. So let's look at an example. We have 2 to the 8th, 8 to the 2nd over 8 to the 5th. So same base, you subtract it, it will be 2 minus 5, but you know you're going to end up with a negative number, so 8 to the negative 3rd power. It's a negative exponent, so we're going to do the reciprocal. We're going to take that, do 1 over 8, and make that negative power into a positive power, and then simplify, which would be 1 over 5/12. So again, negative exponents must be made positive by taking the reciprocal of the entire exponent expression. And that's how you deal with negative exponents. So let's look at 2 examples dealing with negative exponents. We have b to the 3rd, negative 3rd, c to the 2nd power over d to the negative 5th. Let's take it piece by piece. The b has a negative power, so we're going to do the reciprocal of it, which would be 1 over b to the 3rd. c to the 2nd stays as is, and d to the 5th, negative 5th, would become, instead of 1 over d to the negative 5th, it will be d to the positive 5th and be on the numerator, on top of the fraction. So there you go. So if you have a negative exponent on the top of the fraction, the numerator part, then it's going to be positive at the bottom and a 1 over that positive exponent. If you have it at the bottom, the denominator, then you're going to take that base, change the exponent to a positive, and put it in the numerator on the top of the fraction. Let's look at the next one. So we have a lot of numbers, negative exponents and positive exponents, some at one at the bottom, one at the top. So I'm going to break it down. So the first thing I did was I grouped by grouped by the same base. This one is just the coefficient, so negative 3 over 21 times a, so the same base, negative 4 minus 2, times b, we got same base, so 7 minus 7, since we're dividing the b's. And then the c, the reciprocal is 1 over c to the negative 5th power. Right, let's take it to the next step. I simplified my fraction, negative 1 over 7. I simplified the negative 4 minus 2, negative 6. This became 0, b to the 0 power, and then I just kept 1 over c to the 5th. And then my last step, close to last step, I just kept the fraction, negative 1 over 7. The a, since it was a negative 6, I'm doing the reciprocal, so it'll be 1 over a over 6. Then the b to the 0 power is just 1, but that's in the numerator. And then that's c, 1 over c to the negative 5th. I'm doing the reciprocal, and c to the fifth will end up on the top on the numerator. Then I simplify further, so it'll be negative c to the fifth over 7a to the sixth. And that's my final answer. Again, when you have this type of dividing monomials, just break it down into like components, same base, not coefficients together, same base together. And then if anything is negative on the bottom in terms of exponent, it'll be 1 over that term. Or if it's on the top, then you do the reciprocal of that. Okay. All right, so we have an example where Mohammed and Mateo are simplifying negative 4 x to the third over x to the fifth. We want to know who is correct. So Mohammed did his work, and Mateo did his, and Mohammed got his answer, and Mateo got 1 over 4x squared. So who is right? So let's look at Mohammed. So we got negative 4x to the third over x to the fifth. Okay, so let's see what he did. He had the negative 4 out there. Then, this one, let me change that. That's supposed to be that. The 5 got big, so it was supposed to be small. So this is what he did. So he did he did 3 minus 5, okay, because we have the same base, so we're going to subtract. And then he had ended up with negative 4x to the negative second. All right, nothing seems wrong with what he did. Now let's look at what Mateo did. He actually subtracted the base, same base, he subtracted the exponents, but then look where he put the 4. He put it at the bottom and made it positive. But again, negative 4 over 1 is just negative 4. It would not result in 1 over 4. So he did the reciprocal for no reason. So now, again, he just, based on his mistake, he continued and it ended up with 1 over 4x squared. But the only thing that he did right was have the x to the negative second power and then brought it down, did the reciprocal, and then made the x, the 2 positive. But I think the mistake that he made was doing the reciprocal of negative 4, which there's no reason for him to do that. So let's look at if we were to simplify what Mohammed did, he would have the negative 4 on the top and then the x to the second power to the bottom. But between the two, the one who has it correct is Mohammed, because he did everything correct. The negative 4 stayed. Negative 4 over 1 gives you negative 4. And then he subtracted the exponents because he divided the powers, same base. And then he left it like this. But if you were to change it, it would be in the green form, the last part. So Mohammed is correct. Mateo just made a mistake because he made this negative 4 into a reciprocal. Right. Okay, so we reached the end. Going to do a recap. Alright, so we learned about quotient of monomials. If you have the same base, based on the rule of same base, when dividing powers, you subtract the exponents. And if you have the power of 0, anything raised to the power of 0 will always equal 1. Negative exponents must be made positive by taking the reciprocal of the entire exponent expression. So if you have, example, 8 to the negative third, do the reciprocal, 1 over 8, and make that negative exponent into a positive exponent. And that's the end. So if there's any questions where you're confused with negative exponents or power to the 0, please feel free to email me and I'll give you more examples to help you out. And hopefully you'll understand. So that ends our lesson, and have a good day.